Hello, I am Pradyumna from ECM. Today we are here to discuss about round robin, a subtopic of CPU scheduling. First, let us speak about scheduling algorithms. Scheduling algorithms are divided into two parts, that is preemptive and non-preemptive. Some algorithms comes under preemptive and some come under non-preemptive. So first let us learn what is preemptive. Preemptive is when a process is in ready queue and it is transferred to CPU to process. If we can interrupt the program in between and take it back to ready queue, then we call the program as preemptive. And if once the process is started and we cannot terminate the process, so if we like, it is like if we start a process in CPU and it can only uh, it can only end the process after completing the whole process of in the burst time and then giving it to terminal, that is called preemptive. And these are the algorithms that come under preemptive and non-preemptive. First, speaking about preemptive algorithms, there are four types. Those are SRTF, that is shortest remaining time first. That means whichever 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 processes need the shortest time, they will be executed first. And similarly, there is also we also have LRFT, that is longest remaining time first. And then we have round robin, then we have priority based. And coming to non preemptive, we have five types. Those are FCFS, that is first come first serve. We can also call it as FIFO, that is first in first out. And we have SJF, that is shortest job first. LJF, longest job first. HRRN, highest response ratio next. And then multi-level queue. So these are the algorithms that comes under preemptive and non-preemptive. Today we are here to discuss about round robin, a, a algorithm that is listed under preemptive. So when preemptive is occurring, there are some protocols for which a program converts to turns into a preemptive program. The first protocol, that is time quantum. So when we are processing a program, we assign that if we assign the time quantum, that is like we have to the program has to execute for the particular amount of time. That time is called time quantum. So even if the program does not complete in the given time quantum, the program terminates and sends the running process to the ready queue, and it will take a new process that is in the ready queue. So that is time quantum. And another one which we have is priority. So the program takes in the the CPU takes in the processes that require the most priority at the given point of time. And round robin follows a protocol of time quantum. And so starting to see about round robin, first CPU is assigned to process on the basis of FCFS for a fixed amount of time. So this statement tells us that if the programs in ready queue should be sent to CPU on the basis of FCFS, that is first come first serve, and should be executed for a fixed amount of time. This fixed amount of time is also called as time quantum or time slice. The time which we are assigning for the process to execute or get processed in CPU, the time is called time quantum or time slice. So we can call it either it as time quantum or either time slice. So after completing the time, if the time after the time quantum expires, the running process is preempted and sent to ready queue. So after the given time quantum expires while running a program, then if the program is still not completed, then the process is preempted and the process is sent back to ready queue. Then the process is assigned to the next arrived process according to FCFS, that is first come first serve. Like, and it is always preemptive in nature. So round robin always follows pre always is preemptive in nature, whereas uh, priority based algorithm can sometimes go into non preemptive in nature. So we are mentioning the point, and this is the block diagram of how uh, the round robin algorithm works. So first we have processes in ready queue, and from those processes a process gets selected in with the in the model of FCFS, and then here it checks whether the burst time of the given process is less than time quantum or greater than time quantum. If the burst time of the uh, process to execute is less than time quantum, then it goes to S and executes the process till completion, and then terminates the and the termination is done on the process. And then if the burst time is greater than the time quantum, then it executes for the time quantum. After the time quantum expires, the after the time quantum expires, it checks whether the process executed is completely or not. If yes, it goes to termination. If not, it goes to the remaining process goes to ready queue again. So this process goes on until there are no values or no processes left in the ready queue. Here we have some advantages and disadvantages in round robin. The advantages are it gives the best performance in terms of average response time. So we have best average response time when we use round robin, and it is best suited for time sharing system, client server architecture, and interactive system. So these are the advantages with round robin. And coming to the disadvantages, it leads to starvation for the processes with larger burst time as they have to repeat cycle many times. So as we know, if the burst time is greater than the time quantum, it has to go back to ready queue after completing after their time quantum expires. So if the burst time is large, it has to repeat the cycle for many times until the process gets complete. So it's it leads to starvation of it leads to starvation for the processes. It performs heavily depends on time quantum. So it does not follow any other protocol other than time quantum. So we cannot overrule it, or like its performance heavily depends on time quantum. Priorities cannot be set for the processes. So while using round robin, we cannot set priorities to any processes. Now, let us learn it with the explanation with a problem. So here we are considering five processes whose arrival time and burst time are given below. So if the CPU scheduling policy is round robin with time quantum 2 unit, calculate the average waiting time and average turnaround time. So and here we have values for process ID 1, the arrival time is 0 and the burst time is 5. For process ID 2, we have arrival time as 1, burst time as 3. For process ID process ID P3, we have arrival time as 2 and burst time as 1. For process ID P4, we have arrival time 3 and burst time 2. For process ID P5, arrival time is 4 and burst time is 3. So if we check according to FCFS, the first items in ready queue are P1 and P2. So coming like these are the items listed in ready queue as we go on as we move on with the processes. Now we know turnaround time is exit time minus arrival time. So total turnaround time is first when the uh, when the process arrives and the time process exits, and waiting time is turnaround time minus burst time. Waiting time is like total turnaround time and burst time. So like let us consider like it is simple thing. If a person goes to bank and he goes to bank at 11 a.m. and uh, the process that is required take 15 minutes. So he comes out at 12 o'clock. So The total turnaround time is the time he exits, that is 12 o'clock, and arrival time, that is 11 o'clock. So here we get a turnaround time of 1 hour, and waiting time is turnaround time minus burst time. So turnaround time is 1 hour and burst time is 15 minutes. So he has waited for 45 minutes. So this is how we calculate turnaround time and waiting time. I have given a simple example, and this is gnat chart. So first, the element P1 that we have in ready queue is transferred to CPU. Then it processes for time quantum of 2 unit, and then it goes back. It's as the burst time of P1 is 5, it is not completed. So it goes back again to ready queue, and then P2 comes. The burst time of P2 is 3. So P2 runs for a time quantum of 2 unit, and then it stops again and goes back to ready queue again, and then P3 comes. The burst time of P3 is 2. Sorry, the burst time of P3 is 1. So it runs for one. It runs for one unit of 1 unit of time, and then the termination is done, and it goes back. And the next item in the ready queue is P1. So it comes again, and as it has completed 2 in the previous burst, in the previous process. Now the burst time of P1 left is 3 units, and in that here we again process for 2 units of time, and P1 goes back to again as its burst time 3 is greater than 2. So it completes the process, and we get here we get uh, exit times. Here we note down exit times, that is P3 is exited at the time of 5 at the like as soon as the first time it goes to process and executes for 1 second, it exits. So we have written exit time 5 for P3, and for P1 it goes till here. So this is the last time we mention of P1, so we write exit time as 13. So we complete the whole exit time and calculate turnaround time and waiting time from the given arrival time and the exit time. Now, and we also know the burst time, so we calculate both turnaround time and waiting time. Now, average turnaround time, if we calculate 13 plus 11 plus 3 plus 6 plus 10 divided by 5, that is average turnaround time for each unit is 8.6 unit of time quantum, and average waiting time is 8 plus 8 plus 2 plus 4 plus 7 divided by 5, that is 29 by 5, which is 5.8 units. So this is the average waiting time for average waiting time average waiting unit of time quantum for each process to be completed. So here we have seen algorithm of round robin, and we have also seen how to solve a problem in round robin. Hope you understand it clearly. Thank you.